Everyone. Bob, thank you. Thank Amy. Thank Lisa, everyone at Ohio Concrete for helping set this up and especially with the IT stuff. I really appreciate it. And it's an honor to be asked back. I had such a great time in Akron last year, and it was a real pleasure meeting and getting to know Bob now. Um, Thank you. I always enjoy doing it at Ohio. Heck, I remember I've done talks way back when Roger Jones was still with the association. His name came up when I called the main number, which is kind of weird. Um, but thank you. I will do my best to, my background, I am not an employee of ACI. This is the same ACI background I had for the convention, so I just kept it. I will do my best to not step on the toes of Rick Smith with his industrial floor tack, which was excellent. And Michelle Wilson's, my concrete sister, her presentation that's next on surface defects, which I wanted to do, Michelle. I will try to, it'll look like I'm doing comments about surface finishing or something like that, but it's not, because curing, as you know, just touches so many areas. So I will try not to do that. So we're going to talk about curing. You couldn't think of a more sexy topic to talk about, don't you think? I mean, don't you always come home from work and say to your wife, whoa, did I do some massive curing today? You probably talk about how high you pumped concrete or how high the strength on concrete was, but very few people talk about curing until you do something wrong. Let's just get into it. And there's just going to be a lot of definitions here. And then I'm going to show you some photos of job site curing. You know, you might have done something different that worked better for you. God love you. I'm not telling you to change. Every job is a little bit different. Every mix is different. Every thickness that you're protecting and the conditions that you're working on are more or less severe. And what works one day might not work the next. That's kind of why we started thinking about talking about transitioning from fall to winter. This curing definition is right out of ACI's concrete terminology section, the newer one from 2018. No surprises here. We're talking about moisture and temperature to give that to the concrete that's freshly placed, to almost like a little baby. Take care of it until it can get going on its feet after the first, third, seventh, and then if it is longer, say in the construction of a bridge deck, you might go 14 days, but we'll talk about that a little bit too. This is a hydraulic reaction, just to go through the basics, that we are trying to supply water to these cement grains so that they can hydrate. And then that produces calcium silicate hydrates. As long as you keep the temperature and the moisture favorable, it'll continue. You start dropping below a relative humidity of like 80%, or a temperature down to 14 degrees or less, and the hydration process essentially stops. When I worked at CTL PCA for so many years, we would get prism samples in for doing freeze thaw testing. And when we had too many beyond the capacity of the Logan freeze thaw machines that we had, we would have to put them in the 0-degree freezer, which kind of stopped the maturity until we could get them into test. So that 14-degree temperature is something I hope you don't encounter out in the field. So why are we talking about curing? Well, you want to achieve the full potential that your mix was designed, intended for. And I have I forgot to ask, can you guys see my pointer there? My pointer is at the top bullet at the end, the $sign. You already paid for the mix. The ready mix supplier's responsibility is done. Now it's out of the chute. And as the recipient of the mix, it's now under your care. So if you don't cure, you're kind of leaving we should talk about PSI per pound on efficiency of curing or a mix design. But here, PSI per dollar starts to drop down. So it's in your best interest to do the curing, whatever type it is, and we'll go through a number of those coming up. But of course, the most visible one, because we tag so much to it, is strength. I think just as important is permeability, especially for the end goal of getting durability out of our structure that's with this new concrete. Abrasion resistance kind of tracks right with strength, especially if you're talking about pavements or hard trowel floors. We want really good abrasion resistance for the longevity of that pavement. Volume stability, things don't start to shrink. I'm not going into autogenous shrinkage yet, but a standard mix is not going to start to shrink until you're done with the curing period. And so it's going to reduce shrinkage and cracking if we use that time then to get our joints where they're supposed to be, if they're sawn or if they're tooled, that they have some time to let the concrete get strength before they activate. Unless crazing really isn't that serious of an issue unless it is severe. Boy, I get a lot of calls about that, especially after, say, on a driveway, after someone just got done washing their car and they're drying the car now. And as the driveway starts to dry, the moisture lingers in those crazing cracks and makes it look like something nuclear happened to your slab. That's probably more of a public perception. Crazing generally is maybe due to lack of curing. If you delay the start of curing and you have a relatively rich mix, high rate of evaporation that day, you can get these polygonal shaped cracking patterns. Generally, they're not deep at all, but again, better curing would have you have less of that. Improves freeze-thaw durability and scaling resistance. I kind of put them in kind of the same camp. Is always better with better curing. And with the reduction in permeability, we get a reduction in or a slowing of the carbonation front that is going to come through our concrete, which happens to all concrete. But the longer it takes for that carbonation front to advance to the depth of the reinforcing steel, the better we are. Thank you. So all of this, bottom line, it all contributes to more durable concrete. There's even more positive benefits of curing that I didn't want to take up more room on the slide for. So I've yet to hear. So a question Bob and I had before we started was, are there ever any instances where you don't have to cure? And ACI talks about that in a brief paragraph where they say the environment that you're working in, say if it were 95% humidity, okay, yeah, then curing is not so critical. That's very rare though, that environment will last for your entire curing period, say 7 days. So generally it doesn't happen. Some people say, oh, tunnels, but tunnels will have a lot of ventilation provided, so for the safety of the workers and then later for the occupants. So there's still some drying that happens in there. Or if you work in the Amazon rainforest, well, then you have to worry about damage to fresh concrete if you're working in the rain. But generally, no. In most instances, you're going to need it. Another question I kind of generated myself, are there some instances where you can cure too much? And yes, I got called to a job in Cheyenne, Wyoming a number of years ago for a government post office being erected there. And I go, what's the problem? And they go, well, nothing. We think we did all we could do, but just come out and take a look. So I come out there and they definitely did overdo the protection part. The columns were up and so on partially of the walls, but they closed off the rest of the walls and then added heat and then warmed the mix and then added an accelerator and basically wound up having summer problems in the middle of the winter. A lot of stiffening issues, setting up too fast and things like that. So again, kind of a last slide kind of summary. Don't overdo it on the summary protection. There are going to be some temperature ranges that ACI recommends you for working, say in 305. Also, PCA's design and control of concrete mixtures will give them to you too. Tend toward the lower end of the range. If they say 50 to 70, 50, 52 is fine. Because don't forget, you're going to be going up with the heat of hydration bump after you get the concrete installed, for lack of a better word. Another problem that we fall short on, I would say, is haphazard curing. You get the new guy on the construction team, he just joined that day, and he goes, wow, why don't you go ahead and set the sprinkler up over there and you cure. He doesn't even really know what that is. And we have the sprinkler going, great. And then when the day's over, he sees the sprinkler going, doesn't want to waste water, turns it off. And now we have this wetting, drying, which actually puts stress on the concrete when it is so young and has not developed really much tensile strength to itself. And not to dwell too long on this slide, curing, I made up the word conflicts. Don't forget that when you use a curing compound, what's going to happen after the curing period, or as we continue with the rest of the construction, what's scheduled to go on that surface. Curing compound is generally going to act as a debonding agent. So think before you use that, or you're going to be having to add a step of, say, brush blasting that off to make sure that your subsequent treatment will bond. Check with the manufacturer if that is an issue, both with the curing compound and what the scheduled surface application will be. Post-placement issue, I'll leave that as that. What happens when you're all done with the curing period? Could something still happen wrong? I have a micro little case history to go through. I think it's interesting, and if not, we'll just blow right through it. So continuing on finally. Or did I stay here so long that I froze my screen? Okay, so we all know curing is good. This is a kind of a slide that shows, okay, here, if we're going by percent of 28-day strength, so the 100% would be your 28-day strength right here. Boom, we cure and we get this kind of performance. You don't cure and you fall significantly short. This is the same graph next. I just like that it adds the days themselves, showing the incremental relative change from curing and not curing. It does make a difference. And then later, I'm going to show you two of my favorite slides about curing, how forgiving concrete is if you kind of blow off curing or just are so delayed in it. That doesn't count for things like crazing, but overall strength development we'll talk about, show you that. Here's a slide I like and I use in repair talks that I do. And with today's infrastructure being in such, I think that the ASCE infrastructure report card grade is still at a D. The last one I saw was 2017. But we have so much to repair, renew, replace, and yet the funds are very low. I mean, these are big numbers when you go, how much money we have, but it has to, those dollars have to stretch. The first line here is when we build something, we're kind of set, no pun intended or pun intended, we're setting the bar. This is the quality of our construction. Like a mud mat would be down here, okay? But you construct your job and then it's in service and it'll eventually, just like we're going to wear out and die, it's going to start to deteriorate to a point. Let's use the example you're working on. We're talking about a warehouse floor, and the joints start chipping and they're spalling, and now it's starting to come to what they'll use here as a critical limit, that the lift trucks have to slow down and get over this joint without spilling a pallet. And we go, no, we can't handle this anymore. We have to do the repair. So then we repair that, and if we don't change the conditions, we might come to an even faster dip in the degradation of that concrete unless we change something. So in this, staying with this example, let's say we armor that joint like Rick Smith talked about in the industrial floor section. Back to curing. So if you don't cure properly, you don't set the bar as high as it could be. Okay, and that's important. It does directly translate to overall length of durability before a repair gets done. Enough preaching about it. I think we all would agree to that. So our goal here with the time and the temperature is gaining maturity in concrete. So with favorable moisture and with a warm temperature and the allowed time, we will reach a maturity that we either can finish our curing period or we've achieved the properties that we need to be able to strip forms and so on. Many people think of curing as just one thing. We'll just cure the concrete and we're done. Actually, and another blessing of being able to do these talks is I have to go through and reread all this stuff, and there are things that I knew and I forgot, and this reminded me. So thank you, Bob, for educating me during this talk. It should be thought of as an initial curing period, intermediate, and final. Initial being you this could be as the concrete's placed, and if you think about it, it's almost before, because how you set up the forms, do you need to cover things before the concrete even arrives to keep the temperature reasonable? Or if the environment that we're working in that day, the evaporation rate is so high, we are going to have to do some countermeasures to give the concrete a break here. And that would be things like fogging, evaporative retardant, wind breaks. Note that those things are all not touching the concrete, because at that stage, it's still plastic. The same pretty much for intermediate. It would be after you get it down and maybe you just strike it off with a bull float, but you're not set yet. We're not hitting initial set. You could be using fogging or a curing compound, and those, yeah, you're kind of touching, quote unquote, but we're not marring the surface. And then final curing is when you could get onto it and you lay a wetted burlap down, or a plastic sheet, or wetted burlap and a plastic sheet. That product out there, Berlin, I like that stuff, because it keeps the burlap wet longer, so you don't have to keep re-wetting it. Also ponding, if it is conducive to your site particulars, if you have the room, if you have a way to make a dike to pond something, or sand, or whatever you're going to do to create a pond. And then a curing compound is still okay too, but I guess I took that note out for curing compound. Don't forget, some of these do and others don't have some kind of a thermal benefit to them. Like curing compound does not have a thermal benefit. Ponding, not going to be your curing choice in the winter, and just to keep that in mind. So the curing period is more than just this final one-time shot of just getting it wet. It is actually from placement until the desired properties that you are specified to achieve, or you need for your structure, have been achieved. I'll just go through faster on maturity now because I'm lagging on the first couple of slides here. So maturity is a way to estimate the in-place strength of concrete, and it is a time and temperature-based test in ASTM C1074. So being an exothermic reaction in warmer temperatures, the strength obviously develops quicker, and in colder temperatures, that becomes slower. It's kind of like baking. On the left, if the temperature is high, we achieve our maturity goal, which would be the area underneath in the hash there, very quickly, versus that would be like a microwave example. And the next one, let's say you're baking something, lower temperatures, but for a longer amount of time, and then our concrete comes to maturity. So this, as an example, here is a slide taken out of PCA's high performance chapter, where we're just side-by-side comparison of a type 1 mix that was used for repair, fast track, with 710 pounds per cubic foot cement, type 1, and a 0.3 water cement ratio. So it is high performance. And 18, 24, and 72-hour strength development are shown here for flexural strength. Notice how the insulation blankets, the yellow bar, is so much higher. Now, you didn't pay any more for that mix. Of course, a little bit you're going to have to pay for the blankets and the labor to put them on. But money well spent, I would say, especially in a fast track, say, if this is a pavement reopening where time is of the essence, the blankets pay off big time. I'm just noticing, and this is just me, I didn't bring this whole chapter onto one slide, obviously. The first 18 hours has the highest bump, probably because it's encapsulating some of the heat of hydration from such a rich mix early on. And again, that's a great way to use what concrete's given you, the heat of hydration, and, you know, temperature, moisture, time. That temperature all comes from the heat of hydration as well. So encapsulate it, use it. Don't let it kind of just drift off into the air. And then that kind of diminishes as you go to later ages. And it is a laboratory test. So the cool thing is you can do, once you have the maturity relationship established, you get the temperature history out in the field, and you can relate that back to your exact same material strength development history that you developed in the lab. Now you have to use the exact same material, and the downside of the maturity is you change the mix proportions, then you have to redo your maturity relationship. So it is valuable. It is specific though. I just put this slide up because I needed to take a breath. No, let's say this is it is a slice of a core, and let's call the top the surface of a pavement. There's two kinds of curing. There's external and internal. And with today's higher performance concretes, they have such low permeabilities that the cure zone is really just at the very surface, say 4 to 8 millimeters, maybe more, 10. But down below in the body of the concrete, that cure water does not really reach down there to bring along your maturity. And then I just have a couple of slides on internal curing, which is using pre-wetted lightweight aggregate, or there's also these absorptant polymers that you do that do not increase the water cement ratio of your mix, but brings water down into the mix to be used as the concrete relative humidity drops below 100% after you cast it. And as it drops, there sets up a moisture differential, and the paste can draw water from these little pillows of water down in the interior of the concrete. And once the equilibrium comes back, then it doesn't need that water. But it shows a lot of promise. It's been around since the 90s, and it's becoming more and more talked about and used. Again, just a cool shot because it was one of my most fun job site shots. This is from the top of Tacoma Narrows Bridge before they built the second portion of these east-west two bridges from Gig Harbor to Tacoma. On the left side down here is where the anchorage will be poured. It's about 55 feet thick of concrete. How do you cure that? Well, it's not going to be something that's poured monolithically, and it was one of the more interesting jobs I worked at. Curing was discussed. I reread some of the profiles of Hoover Dam, and if that were poured in one monolithic lift, it would of course crack due to the tremendous heat of hydration that would build up inside the structure. Here this was built with multiple variable lifts, 4 feet, 5 feet thick, and then a certain time span between the next lift, but not too much. So that's one kind of curing. Actually, you might have to have internal cooling to control the heat of hydration. And that's what brings me to the next slide. If you've ever gone to PCA's headquarters in Skokie, in the lobby is a core from the Hoover Dam. It's something I can't walk by almost any time, and I've seen it 1,000 times without staring at it for a while and think, okay, that's the greatest generation that built it. It's just amazing what they did in those days. They used, I heard 600 miles of cooling pipe, 1-inch diameter cooling pipes going through the entire construction to cool down the heat of hydration to avoid these detrimentally high temperatures of heat of hydration. And they placed those in 4x8 cubic yard buckets. There's a wonderful, go on Google and Hoover Dam construction, and Luke Snell wrote a very nice paper on it, and actually his PowerPoint in there. It's really enjoyable. If you're a concrete geek, you'll find it, okay, I'll say it, fascinating, because concrete's fascinating. But here we're using this mat. There's so many things we can do to not to cure, but to even pre-plan on that. The larger aggregates, some are as big as softball, 6 inches. They cut it off at 9 inches. But there are about 4 aggregates used in this, fine, intermediate, and then different size coarse aggregates. But the larger the aggregate we're using, the less cement we have to use. So that's an economy, that's savings in money. And then they also use some reduction in cement content and replacement with some SCNs at that time. But the larger aggregates now reduce the cement content, and yes, it saves money, but then reduces the heat of hydration without detriment to the structure. So very cool. And the photos of the cylinders that their cylinders were 3 by 6 feet. So, and they cast regular size ones too. Regular to them was like 9-inch diameter was the smallest one. But read the paper. It's really fascinating, and it's just another approach on how you're handling massive concrete. By the way, this aggregate size was this for the dam. For this job, it was nowhere near that large. So a thermal control plan was a necessity. A job I got to help a little bit on, and it's still ongoing. This is an artist rendering or concept here, but that's what we're shooting for. And beautiful. This is shotcrete. And when you get done staring at it and someone elbows you in the ribs and going, what are you thinking? How are you going to cure that? Beautiful structure, but you've got all these unusual shapes, overhead curing, side curing, and you're going to say right off the bat, what? Curing compound. But they had a very specific color and texture that they were going for. And then with a lot of people in the area, there was this whole discussion and research about a certain kind of coating that is going to resist people just brushing against it over a while, the oils from everybody just touching, and God forbid graffiti. But that is a very major concern for them to keep the beauty intact and the texture intact, and that initial impact when you enter this structure. Just a fantastic job. But curing has taken kind of a front seat on how we're going to approach that. So the talk was kind of entitled Fall to Winter, but we all know this. We're transitioning through different weathers from summer to fall to winter, and darn it, it's so nice today. If it was a snowdrift outside tonight, this talk would be much more interesting, I bet. But summer we dealt with warm weather. Our problems then were like faster setting and the drying conditions. And when you look at the ACI nomograph on hot weather concreting, so then you know right away these next couple things that are on here about counteracting the ambient and concrete temperatures. How can we do that? Wind speed, how do we adjust for that? Hopefully knock it down somewhere, wind breaks. And then if we have a low relative humidity, how do we help the concrete that way by increasing that relative humidity? And fogging is one of those, and evaporative retardants would be something else. On fall, now that we're getting into this, maybe not today, but it'll be right around the corner. I think we might even snow here in Chicago next week. You get the cool mornings, and then you get the bright sunny days like we have today, and then the cool evenings. Big deal. Well, I'm just bringing that up because what I finally noticed that I do get a lot of calls around this time of year is I got cracking problems. People that place the concrete during the middle of a nice warm day and then go home and then it gets cool. Well, while it's getting cool for you, the heat of hydration is just taking off for the evening. So there is this disparity between surface and mid temperature, so that on what seems like a nice day, you don't really have to do much. Think about minimizing those temperature differentials. I got a slide about that with regard to removing forms and timing that. I had a job in Las Vegas, and they had this cracking on 16-inch clarifier slabs. They were round, and this cracking was kind of turning these slabs into pizza wedges. It was just all these unusual cracking, and they were, in their words, of course, doing everything right. And we looked at the test reports and we watched them and this and that. Everything seemed to be up to snuff. And then I was with my mentor at the time, Steve Gebler, who taught me a tremendous amount. And we were getting ready to go to dinner. We come out in Las Vegas to go to dinner, leave the casino, the hotel we were at, and all of a sudden it was cold. Immediately we looked at each other and goes, that's what it is. And we come over in the morning and said, you got to get some winter blankets out here. And they said, you're not from Las Vegas. Do you know how hot it gets around here? That's not what we're talking about, the sunny days part here. It's the evenings that get so cool when that 16-inch slab bumps up to a heat of hydration that I forget the numbers, but it was significant. Put the blankets on and the cracking literally went away. It's so nice when you can just package a little project like that in like 10 sentences when it took us a while to get to that. In retrospect, it seems easy, but there you have it. And now when we walk into the winter season, temperatures obviously are going to get much lower. So we're worried about the danger of concrete freezing, and we're going to have slower set times and relatively slower march toward that maturity that we're shooting for. So here's just summary of kind of just what I said. I think I covered all those. Sometimes you can get the slab surface to set ahead of the lower part. If you really put it on really cool subgrade, it acts almost as a retarder, if you will. You can make up with that. Just put little. You can adjust the mix slightly, or something more simple. You could if there's not a lot of reinforcing steel over the slab you're doing on grade, you could lay down the same mats you're going to be using on the concrete later on the subgrade, just to keep its temperature down, because they're still in early fall, even mid-fall. You'll still be getting some warmth coming out of the ground. That could help with that. Now, if you do have cold concrete, and say you might have a delay in the setting process, and you'll have probably along with that an extended bleeding period. So watch your finishing time, and I'm not going to talk about finishing because that's in the industrial slab stuff and in Michelle's talk, so I won't go into that. But I already said so. And then ACI 306, I'm going to tell you about a paper at the end that I used as my reference from a good friend of mine, that I am going to, I got approval from him to give it to Bob to let you guys look at. Very interesting. That talks about 306 are the guideline that suggests not placing concrete more than 10 degrees warmer. The surface that you place the concrete against should not be more than 10 degrees warmer, nor less than greater than 15 degrees cooler than the concrete temperature you're placing at. And 301 structural specifications for concrete construction, and 306.1 the spec indicates concrete not to be placed against surfaces that are less than 35 degrees. There's the paper I'm giving you kind of shows there's some disparities in those two requirements. So without reading the paper to you, I want Bob to give that to you if you guys want after the presentation's over. Okay, so this is what's happening when we are getting into the cooler days. The 73 degrees, always the standard laboratory temperature. We'll just say that's just straight on beautiful weather. As we get to cooler weathers, those set times, they all drift to the right, initial and final set. Initial set somewhere around 500 PSI. It's not a compressive strength, that's a penetration resistance. The ASTM for that test is here. You might do something like that in mixed design development. And final set also gets delayed, pushed out a little bit more drastically. Here we go from 4 to 8 hours, and up here it's like 6 to, more than double here, 14 hours it looks like. In the summer, by the way, of course, this line, the 55 degree line, gets shifted to the left of the 73 degree line. So you are well aware of that, because there's no dinking around in the summer. Things are moving fast because the concrete's setting fast. So you don't want those problems. Today's mixes are not like your grandfather's mix or your father's mix, cement, sand, stone, and water. They're a little bit more complicated these days with a 1, 2, or 3, or I guess there's even instances for 4 different type of cementitious materials, but generally it's going to be your fly ash, silica fume, or slag in your mix, and a host of admixtures to make concrete just jump through all kinds of hoops that we never thought we could do before. I'm just hoping that everything in the mix design is compatible. You don't want to find out that it's not when it's in cold temperatures, and you're thinking it's being affected by temperature too much, when it might just be that the mix just doesn't have a cement admixture compatibility or whatever it might be. That said, I'm sure someone would ask me, well, what does this SCM do? I put this slide in here. Those are the general ranges that we should be using these materials in. Of course, if your mix shows it works outside that range, knock yourself out, but this has worked for most people in most instances. I would just say in colder weather, tend toward the lower percentages, because most of these SCMs will retard your strength development initially. then this graph from PCA, Design and Control of Concrete, kind of summarizes what the effects of those are. You're really, I guess I'm only talking about from that previous list is the F and C type fly ash. The slag here and the silica fume are the most common ones used. And for what we're discussing, I did mention bleeding, but for setting time, here's your effects for fly ash type F. It increases setting time. C has kind of a dual up or down, increase or decrease based on the dosage and its chemistry. Slag increases setting time, and silica fume really doesn't affect it at all. Heat of hydration, again, in winter, you'd kind of want to be aware of this. That's maybe one of the reasons I said tend toward the lower percentages in your replacement of cement, because fly ash reduces your heat of hydration. In the summer, that's great. Class C, again, kind of a up or down. Slag reduces it, and silica fume, no. Silica fume is more for, the reduction in permeability, because silica fume particles are about 100 times finer than a cement grain particle, and hence we get the lower permeabilities with the use of silica fume. Of course, it has a high water demand because at that kind of small speck size, it adds a lot of surface area to the mix. So, and as you see up here in workability, it brings workability down. So that's something you would have to counter with an admixture to maintain the low water strength ratios. Okay, I'm getting off the curing topic. So just to kind of go through a couple curing things that we have available to us, we have a lot of choices. Some apply sometimes, some are more convenient than others. So let's just talk about them. Either way, we're trying to keep the humidity high, the temperature away from the freezing point so that we are moving up in maturity. Forms you can leave in place, that's fine. I just have a couple curing related comments because you'll see. But the only thing about leaving forms in place for the most part is people need to use them elsewhere. So it costs money to leave them there, and then you decide on your job what is best. If you do leave them on, you might have to wrap these around with an insulation blanket. Don't forget to put that insulation blanket, no matter if it's cold or not, to put it on top so you don't neglect the top surface of a column or a wall, something like that. If you're going to undo them, undo the forms, and then follow immediately with a secondary curing method. If it's not cold, you can use water, but otherwise curing compound, and in order to reach the degree of maturity that you're looking for to be equivalent to, let's say it's specified as a 7-day curing period. I kind of said that with the coupling it with the insulation. And there's other ways too. You could have, don't overdo it. If you have say this column and you happen to build an enclosure around it, I don't think you got to wrap it, do both. Put it in the enclosure if you're going to heat that, and then heat this. No, then that would be probably overdoing it. And of course, the best way to tell is to monitor the temperature of that. You could do that with thermocouples or a thermistor embedded in the concrete and track that. Worked on some cool projects. This was the Chicago Museum of Science and Industry U-505 German submarine. I almost call it a coffin. They put this underneath the front lawn of the museum because the submarine display was outside for so many years, and the acid rain was literally starting to eat away at the shell thickness of the metal submarine. So to preserve it, they put it in this humidity controlled I should have added more slides. It's a tremendous exhibit. It won best exhibit upon completion of construction, best exhibit in the country. And we had our ACI dinner there that next morning, right next to the submarine. It was really cool. These walls were placed 5 feet thick at the bottom, 3 feet thick at the top, poured from the bottom up, pumped vertically upward, and externally, so you can imagine the pressure on these forms, external vibration. I'm coming back to curing. They left this forms on for curing, and then the question started, what are all these lines? And here you could almost see a reflection of the reinforcing steel. Our meter cover depth, it was fine. It was at the depth it was supposed to be. And then as the concrete kind of broke free or shrunk slightly from the side of the form, there was this condensation in the micro space between the form and the cast concrete, and there was what looked like to be a dripping, and the architects wanted it analyzed. Oh my God, we worked on it and didn't think it was any concern. And the punchline, the bottom line to this whole story was they painted it all anyway. So a battleship gray. So these beautiful walls, which would have been wonderful to see as is, were painted gray. But still a tremendous. Oh, there's a shot of the forms in place, and it was a great job. Good concrete work by this contractor, exemplary work. Another, here's a shot of a external vibrator. They would move them around as the concrete placement proceeded upward. It's a great way to place them if you have the pressure resistance of the forms, but the vibrators are kind of, I guess I'll say expensive because you have to handle them. So they would just move them up as they go, because once the concrete level rises, then that vibrator is not needed there anymore. And you don't keep going up if there are voids. Otherwise, it won't build on itself. So it's kind of a self-policing form of placement. But it was very nicely done. So when do you take the forms off? Here's a great slide that's in the EB1, I call it EB1, PCA's Design and Control of Concrete Mixtures. You place something, and the surface temperature, the heat of hydration bills in the member placed. The surface temperature is kind of kept close to the up here, but once you take the forms away, then that surface temperature drops off. Here's the dashed line here is if you kept the forms on. That's 7 days. Once you take the forms off, now we've got greater and greater, and the rule of thumb is you want to be less than a 35, 36 degree temperature differential. And that is a rule of thumb. As you have this heat of hydration, you're actually kind of delivering maturity to your concrete, and that heat helps develop its strength. So as that time and temperature advance, the 36 degrees becomes you can move past that and go to greater and greater differentials, temperature differentials that the concrete can tolerate without cracking. But that again depends on the ambient temperature that you're cooling it to on that form release, what the mix design is, and so on. Or if you do release the forms, again, like I said before with the picture with the column wood form, what kind of curing that you come back to replace that with. This other graph that I really like, it shows that the forgiveness of concrete. Here, of course, the 73 degree line is if you cured it straight away all the time, and the concrete strength just keeps going up, at least graphically here. If you neglected the curing and it's out in a cold environment here, 25 degrees F, and then reinstitute the curing later. No, you don't come back up to where you would have been, but concrete still rebounds nicely, and you still might be, hey, say if it was a 4,000 PSI spec, you would still achieve that goal. Yeah, like I said, it's not as high as you were had you done everything right the first time, but concrete in that, I just think it's very forgiving. I had a project at a casino in the Midwest that the contractor was doing great on, and placed a second floor slab and had everything protected, like we'll show later with the enclosures with column to column visqueen to have an area to heat in. But in the night, a very big storm blew everything off, and they were very afraid that the concrete froze and they'd have to rip the whole floor out. And long story short, they sent a couple cores. We subjected them to accelerated curing, so higher temperatures, in order to kind of send a canary to the coal mine saying, is it still salvageable? And we said, if you put the protection back and heat the area, you should be fine. And they were 2 weeks ahead of schedule anyway, but they wanted to know pretty quickly. So that's why we had to accelerate the curing, that if they wanted to just rip it out and redo it, they could just get back on normal schedule. But it was nice to help a contractor who had already marched so quickly along on the schedule to just keep going, in quote unquote. Leaving forms on, just a side comment, because this always seems to be a cousin of being called out on a curing issue on a troubleshooting job. Look at the condition of the forms. It might not be, and the next example I show you was not an architectural job, but someone will start complaining about, hey, I don't like how that looks. Well, what are you asking for? If this is going to be buried, that's a non-starter. If this is not an architectural job, that's really not a requirement of what the contractor's doing, but to keep it in mind. So is it staining? Is it because forms are old and highly absorptive, and maybe that darker color, this looks like it's stained, but darker color could actually be a superficial reduction of the water cement ratio at the surface, which in a way is a good thing. Or when you look at the edges of these form lines, is this because the edges are beat up and we've had mortar loss over here? Looking closely, we're kind of too far here to do that, but that would be more of a concern to me, that if we lost paste and there's almost a, call it a mini honeycomb area here where mortar or paste has escaped, and now I'm seeing exposed aggregate. But that's just I don't think that's the case. Just talking about the form condition. Here was a job downtown Chicago on kind of a high-end hotel being constructed, and if you didn't have your attention drawn to it, and that's, I'm going to come back to that as the end statement. It's not a big deal. The general all of a sudden started noticing, he goes, I got tiger striping, and he did not like this surface appearance, and it was variable, modeled, whatever you want to call it. And he's looking at all this, and he's starting to tell the concrete sub, you're not doing a good job. But they really didn't do anything. I start looking at his forms, and this was the variable condition of his forms, which was being reflected in the work, and they left these forms on for quite a while. I'm just inserting the word now, cured by leaving the forms on. It was more of just a timing thing on releasing things. But they did have some maximum uses for these forms, but no one was enforcing it. And it only came to light once this kind of variability started to show up. I really started to like this general contractor though, but he had no specification leg to stand on. There was no mock-up made, and I cropped the top of the picture out to not show the company name, but he put these notices on each landing and told the guys, I don't want any food up here, tobacco. You can see the list yourself. The garbage that winds up being thrown into a floor form, and when you strip, gets seen when you remove the forms. My favorite is, and I've seen this, gloves laying at the bottom of a pour, bales of tie wire, which is going to be a staining, corrosion staining issue. It's so avoidable. So is that initial curing? That's prep before even placement. And he does talk about blowing all the sawdust out down here. I love everything he has there, but another thing I cropped out, I go, how tall are we going on this job? He goes, I go, we're on the 11th floor. What floor? He goes, 11. So he didn't call anybody out to look at this until the 11th floor. It was not in the specs, so I told him it was not something that was designed. And if you didn't do a mock-up, say for a less critical wall, like a basement area, to do a mock-up and have that to be your on-site referee for what is an acceptable surface appearance, none of that was done. The job completed. The architects never noticed this. Just saying, there are conscientious people out there, but maybe they don't have the specs behind them when they want something better developed. Continuing on, here's a job I worked on for a number of years ago. This was the rehabilitation of the St. Lawrence Seaway lock walls. It was a very interesting job. It was a litigation project, but they would blow off the walls with explosives after doing close line drilling. That's what all these vertical vertical drill holes are, and they would set explosive charges in every alternating hole and then blow them off. The big thing that was going on here was the whole project was about cleanliness. After everything was blown off, then they had to chip off anything that didn't get blown off perfectly, which was a big major hassle. And then there was a lot of dust here, so you had to wash off the wall. Sounds easy, but you're washing all this dust down and it accumulates thicker and thicker as you get down. It was a huge problem. Add to that, you know, 10 degree minus 10 degree temperature, and it's onerous to say the least. But I put this shot up because the paper that I'm going to have you take a look at for protection during the winter has some interesting comments. These guys in the middle of Canada, or you know, in Canada, they would set these forms. They're about 1 meter thick, new cladding, and as cold as it was, the forms were set up, and then heaters were blowing inside the forms to warm everything up prior to the pour. And we had to crawl inside the heaters too to look at the surface prep and everything. And it was more comfortable being inside the forms when the heaters were on than out in the middle of this cold gangway. There was, and surrounded by nothing but ice cold metal. But when you read the paper that Ron Kozakowski wrote about winter strategies, it'll make you think and about how much protection is really needed and what's best to do. Just let the concrete warm the subgrade, or if there's any metal, massive metal, not there were just minor rebars just to hairpin this to the side, or do you heat the forms and the concrete and then keep it heated after that? It's very interesting to compare 3 scenarios that they use before the concrete and the substrate or the steel come to equilibrium, and it's from the standpoint of the contractor, makes a big difference in terms of money being spent on that, especially when a great sentence in this article said, and as we all know, all construction projects experience delays. So if the contractor's been heating something for 3 days and then all of a sudden it's delayed till Monday, he has to keep heating it. Otherwise, what he heated before will be for nothing. And then when it's all said and done, he's been heating it now for 5-6 days, and whether it was 3 days or 6 days, the 3 extra days does not increase the quality of the concrete that's being placed at all. It does keep it safe, but is it economically sustainable? Something that should be thought of, and especially discussed by the contractor, maybe even in a pre-pour meeting, and so on. At the time when we watched all that heating, we go, wow, it is sure cold out here. But when you start seeing research about the effects of the heating versus the outcome on gaining to maturity, it's very interesting. Did I freeze here? No. Okay, so we already talked about initial curing. Those are the things probably before, when the concrete is still plastic. So this might be fogging when, say, with the silica fume mix, very hard to see the bleed water coming up because of that high fine surface area of silica particles. And if you have a high rate of evaporation, it might look dry. One way to kind of check on that is to put they say plastic, but if you ever used one of those garbage can lids, those plastic ones with the little dome with the handle on there, to just put that down on the surface and to see after a couple minutes if there's moisture underneath there, then there's actually, in the absence of that evaporation, the bleeding is still continued, and you could maybe do fogging if it's not too cold, or if the wind breaks, if it's not too late, to at least avoid finishing a slab that's still bleeding and winding up with a delamination from encapsulating bleed water still exiting. Fogging. I'm going to start going through some of these a little faster. Fogging, what you're trying to do is increase the relative humidity over the very surface of the flag, not directing that fog spray, which is an atomized water spray, into the surface, but the 5 feet above to increase the relative humidity there. Another shot. Now this would be bad fogging. The atomizer nozzle is evident here, but here it's kind of just like a It's too heavy of a water spray, and it's going to be damaging the surface. Well, it's not going to damage it because somebody's going to keep on finishing that, but finishing that water into the surface, and then we have a weakened high water cement ratio surface that'll dusk and not be very high in abrasion resistance. Here's a job we worked on at a skating rink in Hyde Park, Chicago area. Kind of a big deal because the mix had corrosion inhibitor. We had everything going on, and very wide, flat, open surface, and it was kind of a windy day. And the guy here with the red Hudson sprayer is spraying evaporative retardant, or they call it reducer now. Great. You can't really do anything else in this area because you have no windbreak capability here. The only caution on this is it is shipped generally. It depends who manufactures it. They all make them, all the providers like Sika, BASF, Euclid. But for shipping, they're generally in a concentrated form, and you'll have to add 9 parts water. So it's still 90% water. Don't use it as a finishing aid repeatedly. It'll wind up being the same thing as blessing a surface and increasing the water strength ratio there. Pervious paper. I don't see that much of it used here, but just like anything else in a plastic sheeting, or when you have this is like a sidewalk, or you have a slab with you come to the corner, bend it around the sides, because at those corners you have drying on 3 sides, top and on the perpendicular edges. So tuck it in around there with another 2x4 or sand or some of the rocks to keep it from blowing out of place. Sprinklers are okay if you don't put the burlap on too early. That leaves the impressions there. You got to keep the sprinkler going. That's why whenever I see this is hopefully just preceding putting plastic over it so that it stays wet. Overhead shot of a paving train with the curing bridge following behind and laying out the burlap as well. Plastic sheets, probably the most common thing you see, especially on residential construction. Looks common, just some things to watch out for. Where you lay the timber, good. You're good from the standpoint of not letting that blow away. But all those patterns of the little what do you call them, little fish mouths or bubbles that you have there are going to be reflected in the concrete surface, and someone will complain. Lay it flat is the easy answer. People go, well, I don't want to lay it flat. Well, then I can't help you. If you can stretch it out and lay it flat, and then put, say, a insulated blanket down on it, those battens that are kind of a little stiffer, they can help keep that down. I had one job where they put like a styrofoam on top of this because it kept everything nice and flat, but you had to weigh down the styrofoam too from not being blown away. But then if you did that and you could put this wood on top of the styrofoam, then there won't be any kind of mark from the styrofoam that would have been dissipated through the fiberglass. So wet burlap and plastic, I'm going to come back to this picture. That's okay, and this is not okay. Again, people kind of go, okay, we're done, we'll be back on Monday, and stuff gets dry, well, gets blown off and then dries. So there has to be some, you have to keep an eye on this. Here's that picture that says those shapes in the plastic will be reflected in the final product. Yeah. So that's the case for making it, laying it flat. Curing compound is probably one of the most convenient things you could do. You add the pigment here so that he can see where his coverage extends and that it's uniform. So here's good application, and here's what looks like is a bring your kid to work day in action. You can't have that nozzle clog up. If you guys have ever worked for your chapter on a Habitat for Humanity project, or if you haven't, do so. It's enjoyable. We all rotated on ours when we did a bunch of driveways and sidewalks for a community. And when I got rotated to curing compound, number one, spray it downwind. I got a face full of that, so my face stayed hydrated. But keep the nozzle clean too. And one of the best ways is just to keep it going. That's enough said. So apply that as soon as you possibly can. If you have, say, a rough wood formed or scratched shotcrete surface, you'll have to apply it probably in higher dosages even than it's recommended. And most say to apply it in 2 perpendicular directions. Again, watch out for what's going to be happening afterwards. And then again, this does not have any thermal benefit. A job that I worked on in LA County for their sanitary district, curing. Boy, it was so hot, and shotcrete mix is relatively rich. It is rich. And drying conditions were just all over. They really fought against this and did a very good job. Wind breaks and immediately covered things as soon as possible. We even had test panels with field cores that we extracted at the days from the site just to keep as close to what we were doing, because this was a very thin overlay of concrete that had been quote unquote corroded, not in the corrosion of steel way, but due to the low pH of the effluent that's in those tanks. It kind of softened the surface and compromised it. So we removed that with hydroblasting and put back a shotcrete overlay. I am sorry, I'm getting close to my time, but I'm going to get these last couple in. Ingenuity of curing here by this shotcrete contractor on this project. He basically took Berlin and kind of made a shower curtain out of it by hanging it vertically, very tight to the wall, with soaker hoses, keeping the environment for like it was like an inch or so with an air gap in there, and he kept the humidity or the wetness on there very, very nicely. Appearance wasn't this big because it's going to just be a tank for poop, so appearance was not an issue. In fact, this project won an ICRI, International Concrete Repair Institute Repair Award. I won't even tell you the year that happened. Similar, this is from a paper from ASA, American Shotcrete Institute, on curing pool walls. Kind of a similar thing where they lay soaker hoses on the top bond beam, which is the beam all the way around the top edge of the pool, and then run the water down with soaker hoses. And then as it comes down to the bottom of the pool or the bowl, they can repump that up and keep recycling that water, which is good. Again, vertical, with shotcrete, you don't have forms, so there's not forms to leave in place, but these guys wrapped in plastic and it worked out well. This is the nomograph for hot weather concrete that I referred to, and that's when you have to initiate a protection and counter either the air temperature, the relative humidity, the concrete temperature, or the wind speed. So wind speed, wind breaks. Concrete temperature, ice, chilled water, and God forbid if you have, unless you have the money for the job, liquid nitrogen, which is great, or fogging to offset the relative humidity. But whenever it starts to, most of these standards say when you approach, when it exceeds 0.2, but even in last week's talk, Rick Smith was talking more about 0.1 pounds per square foot per hour evaporation rate seen on this scale. There are specs that are calling for less than 0.2. So just to be aware of that. Okay. Here, this was a job for the Navy, a damage control school. Very hot conditions for this construction of this 5-foot thick slab, but they used fogging and then Berlin white to reflect some of the solar loading coming down there. They would wet the Berlin and then flip it over, and it worked very well. Internal curing, I mentioned at the top, and since I'm almost out of time here, this is from Acasa Lightweight. They are a provider of this lightweight aggregate used for internal curing. Again, it puts water for hydration, not increasing the water strength ratio, into the middle of the mix. But again, a reminder, that does not mean you stop the normal external curing. It's in combination with. Those are the insulating blankets that I mentioned before. If you're going to use heating, that I mentioned before about keeping the plastic down and keeping it flat. If you're going to be using heaters, use indirect heaters. Here's a schematic from PCA versus a direct fired heater, which sends CO2 into your work area. And when it comes in contact with fresh concrete, it will carbonate the surface and cause dusting. Not the dusting you clean up with the dustpan. It's a surface that has soft and is carbonated, and you don't want that. It's a pain in the neck. So here's the schematic for this kind of heater. If you can see the flame and exhaust come out, then that's a salamander. It's okay to keep the area warm, but not around fresh concrete. Old school, just to put a slide in like this, people, I guess, still use this. It's a pain in the neck, though, of getting rid of it. It's a fire hazard. But if you do use it, it works. I would put plastic down first so you don't have straw impressions unless you're going for that. And then a layer on top of this to make like a straw sandwich so that you keep the straw dry. Otherwise, it loses its insulative value. I am not going to give you the example of what happened here. I'm just going to go to the punchline. This was a job I worked on at a prison. Floor slab, the contractor, they put the vapor barrier underneath in the right place, and there was problems. The contractor got discharged off the job, and we goes, we'll hire somebody new next spring. And the slab sat out in the winter, exposed all winter. But everyone did what they're supposed to, except he finished it early and got discharged because it had a delamination in the surface. And cores looked at that, and it looked like your typical delaminations, and we could work with that. And a little closer look up at it. Yeah, there it is. And then I work with the same petrographer I've used for 35 years now, and he suggested impregnating the surface here with blue dye. And what an eye-opener. That non-air trained slab, which was hard troweled, non-air trained, so it's not designed for exterior applications, sat outside in that winter all winter long, and the freeze-thaw damage extended about 2 inches down. Amazing, but not, because that's not what interior concrete is designed to withstand. And back to this little schematic that I made up from clip art. So this is the red would be the vapor barrier. Any crack or joint that had snow sitting on it, that snow would eventually, freeze and thaw, melt, go into the joint and never come out, would then saturate both sides of that joint. And when I first got called about the job, they go, "We have a joint problem." And then they called back a week later, go, "No, this joint problem's grown." No, it was a delamination problem. That's what started looking at it, everything a lot closer. And then we found out that the damage was much more severe than first impression. And I'll just end it at that. So avoid the freezing for the cold weather, because it can reduce your properties and strength of your concrete by 50%. But that's just 50%. But that's just in the frozen zone. If you catch this early, again, you got kind of have two thermoclines fighting each other. You have the cold from the top working its way into the body, and you have hopefully still the heat of hydration resisting that. So that freezing, how far it goes, is important before you decide on what you're going to do to react to that. It might just have to be milled off. On that job where I said the casino in the Midwest had the protection blow off, it was very superficial. It looked bad, but once we got a core and then saw how deep it was, and most casinos have carpeting over their surfaces, so it was not as big of a deal for them once we removed this. So it's just, when we say 50% reduction, it's just what's frozen that did not reach the 500 psi penetration resistance early on. That is freeze thaw damage, not to be confused with freezing of paste. Here, this is over years and years. It's an upside down core. Here's the painted surface of the pool that this cracking extended well past 3 inches. If you're going to fix this, you'd have to take it down to sound concrete. But they actually removed this pool. Okay. Winter concreting is, I'm already way over time. I don't want to bore you guys with what you probably know already, but it's the same as fall, only more so. You are more conscious of protecting against freezing. So in this picture, you can see a lot of things going on. You see the windbreaks, and you see the steam coming off the bottom. What you don't, off the concrete, what you don't see is there's heating underneath this slab. So they're doing something good, but not overdoing it by capping everything off and heating everything in the enclosure on top of that. Hydronic heating systems can be used here. If you use the hydronic heating system and cover this with insulating blankets, you can keep the subgrade warm. These same kind of systems can be used on the side of walls, but you're going to, again, have to add insulation. Enclosures. This was next door to me in my subdivision, where the contractor basically put up circus tents and the guys could work in short sleeves. Durations will depend on the thickness of the member. This is temperature drop after your curing period is ended after 24 hours, say. So the thicker the concrete, the slower the allowable temperature drop is, because you have that disparity between the internal temperature from heat of hydration versus the outer temperature from reacting to the ambient air. And then how long, these tables are also from ACI in terms of how long do you provide that protection. Depends what the structure is being used for, and is it loaded, unloaded, exposed, not exposed. I won't read that to you. And this is the last slide. We didn't even talk about crack control for concrete really much, but hey, concrete is not going to be cracking until it starts to shrink. And here, the tensile strength of concrete starts to grow, build as we're curing it. But once the curing's over, the tortoise and the hare race begins, and then this tensile stresses start building up in after that. But we have all this time to get our joints established, meaning hopefully activated, so that we don't have uncontrolled mid-panel cracking, which no one really enjoys. Okay, sorry to go over everyone. Just I'll leave you with a couple publications that I re-enjoyed as I did my research for this. CIP from NRMCA has some great publications, and all of you guys who are members probably have them already. And then these other ones, here is the article that I'm referred to a couple times. I already sent the copy of this to Bob to give you if you want. I think it's a great article, and I got Ron Kozakowski's okay to share that with you. But like I said, these are other great sources for information on curing in cold, hot weather, and also not to forget about PCA's Design and Controlled, kind of the concrete Bible that everyone's been using for years. Sorry, I ran over. So I gladly would take questions if anybody's still here.
All right, George, let me jump in at this point. Everyone, you're free to stay on for the question and answer period. There's just a few, but I do want to mention that George's 5-page document will be sent to you automatically. You'll also get a copy of the slides. You'll also get an archive of the presentation, and then of course you'll get your certificate of attendance. So feel free to stay on. We hope you do. The question and answers are always a very informative part of this, and we don't have a lot, so I'm going to jump right in. George, your break is over. So the first one is from Ken Kuhlman, who's out in the northwest part of Ohio.
Oh, that warms my heart. Yes.
A little closer to you. He's asking, and of course you're going to be a little afraid of this question because it's going to go in a little Michelle's presentation next week, but can you discuss curing and mortar flaking on exterior concrete?
Well, mortar flaking generally is associated with early salt application. That's how I see it. And or you already have a surface that's finished due to poor finishing, and it might be years before you abuse that surface, but putting salt on it later. I worked on a subdivision here at Burr Ridge where a lot of the White Sox players lived. And I was in this subdivision doing for the insurance company. They had their driveways blow up, and they had a strict no salting policy. Well, then we had a killer winter. I forgot the year. And they go, you just salt here, don't worry about it. And all the surfaces blew up. And that was many years after initial construction. So maybe those surfaces were already sprinkled with water and blessed when they were finished. I don't know. But mortar flaking is different than, I usually have a slide of this in my agri talk, is different than pop-outs, okay? Where pop-outs is more of a material problem, and mortar flaking could either be aggressive service condition like the application of salt early, or bad finishing practices.
Okay, great. Okay, second question is from Tom Razitz. As he says, many homeowners want a picture-perfect slab. What's a suggested technique to remove the curing discoloration when they do use plastic sheeting?
Screw them. No. I'm kidding. Well, it sounds too simplistic, but yeah, you gotta lay it flat to the point where I didn't come back to it. That first picture with the curing, and then not how to cure with the plastic sheets, there was a lot of penetrations, okay, like a vent cap or something, and then the plastic sheeting was just tented over that. If you really want to do the job right, you almost have to do that, because plastic sheeting is not that expensive. You don't need really heavy stuff. 4 mil might do the job. You're going to have to slit that there and almost lay it down like you would be placing a roof membrane down, and tuck it around those kinds of openings to keep it all uniform in contact with the concrete. I'm sorry, you saw those PCA pictures of with plastic and then removed. The impression stays. And Tom, just going down the load, somebody's going to, what can I do about that? If you place a sealer on it, to me, it locks that color in. Now, if you want to use a pigmented sealer with a stain, that's different maybe, but I think the contrast of light and dark will still kind of stay, maybe a little bit muted, but it's going to be hard not to notice. I'm sorry.
All right, great, George, thanks. And then he had a second question as well. What should someone do if they're not sure what curing membrane compound was used before applying a penetrating sealer? So what's your recommendation there?
Well, great question. Really great question, Tom, because I like penetrating sealers. I'm not a big fan of a surface sealer because it's going to get worn off, and in a non-uniform way. If you put it on your driveway, it's going to wear off where the tire tracks are, okay? And now if you apply a penetrating sealer, it won't penetrate, at least as well, in the areas that still have remnants of the first curing compound on it. So if I was going to schedule a penetrating sealer, I would water cure, let it dry, and then, oh God, can you see my hand? I use this analogy. This is the top of the concrete, and these fingers, the spaces between the fingers are the pores. If the concrete's saturated, those pores are full. So after you use a water curing, let it dry to musical chairs, make those pores available for the penetration of the penetrating sealer. Does that make sense? I'm not adding, if you're saying compatibility between the two, then you got to talk to the manufacturer of that sealer. I would think that they would have both products, and you see what they say. Use our product here, then this, but ask about when is it dissipate, and don't take the answer in 28 days. That's very arbitrary.
All right, great, George. Okay, one final question we have going at the moment, and it's going to be a tough one for you. Dan Hunt is asking, what is your opinion of internal curing admixtures as an alternate to lightweight aggregates for internal curing? So we've seen a couple of these hit the market. So,
Dan, are you calling internal curing admixtures like a SRA or shrinkage reducing and shrinkage compensating versus you can't answer. Can you answer me live? Well, we had nice discussions of this in 301. Scott Tarr led these, and they were very interesting in terms of what is the compensation, because if your shrinkage is X and your compensation falls short of that, is that enough? So you got to get the dosage right. And is that dosage trying to hit a moving target if we're adding water in the field? So then the shrinkage will be more. So the lightweight aggregate, I'm thinking, might be more predictable in terms of being forgiving in the, I shouldn't say that. I didn't do, I can't opine on that. I didn't do a side-by-side comparison. So I should just stop there.
Okay, great.
I'm sorry, Dan.
Okay, with that, thank you everyone for taking your time to spend your valuable time with us today. We appreciate it. We appreciate George. Thank you for a wonderful job. A lot of people stay on the line to finish this out. And I would just want to mention that next week, Michelle Wilson will be doing a presentation.
Who's
that? She's going to do one on surface defects. Same time next week, you'll get an update for your Zoom registration. So thank you again, everyone. You're free to go, and we appreciate your time. Thank you.
And sorry I ran over. Yeah. Bye-bye.
Bye.